Hello everyone, welcome to History and Culture. In March 1974, farmers in Lintong, Shaanxi, accidentally discovered fragments of terracotta figures while digging a well, marking the emergence of the terracotta army of Emperor Qin Shi Huang. This discovery not only made the terracotta army a world-renowned archaeological heritage but also sparked numerous mysteries, drawing widespread attention from both the academic community and the public. One theory suggests that each terracotta figure is lifelike, with varied forms, almost resembling real people. Some even believe that the firing technology used by the ancient people is so advanced that it remains difficult for modern science to replicate. Could these terracotta figures really have been made by firing living humans? This, however, is not a convincing explanation. There are also rumors that the colorful paint on the terracotta army when it was first unearthed was actually a superconducting material. This sounds like something out of a science fiction novel. Could it be that people in the Qin dynasty, over 2,200 years ago, discovered and used superconducting materials? Did the Qin people travel to the modern world, bring back black technology, and use it to decorate the terracotta figures? However, after research by scientists, it was indeed found that the blue paint on the terracotta army does have superconducting properties. So, what is really going on here? Let's explore the truth behind the terracotta army and its hidden, black technology. In ancient times, the earliest synthetic blue pigments made by humans were mainly two types, Egyptian blue and Maya blue. Egyptian blue is one of the earliest synthetic pigments in the world, with a chemical composition of calcium copper silicate. As early as around 2600 BC, the ancient Egyptians used this pigment to decorate objects, making it the earliest artificial synthetic pigment known in history. Maya blue, on the other hand, is a pigment made from a mixture of indigo plant extracts and palygorskite clay minerals. American scientists discovered the composition of Maya blue, but to this day, we still don't fully understand how these two components can combine stably to form such a vibrant and durable color. The manufacturing process of Maya blue remains an unsolved mystery. The blue color on the terracotta figures has been named Chinese purple by scientists. It is a pigment similar to Maya blue. The uniqueness of this color lies not only in its vividness and durability but also in the remarkable similarities between its metallic components and superconducting materials. According to relevant sources, humans did not rediscover blue until the Industrial Revolution. So where did the blue pigment on the terracotta army, from the Qin dynasty over 2,200 years ago, come from? Experts have proposed a hypothesis. Perhaps during the Qin dynasty, China and Egypt already had trade relations. Egyptian blue pigments and carving techniques might have been introduced to China and later applied by Qin artisans to the terracotta army. This hypothesis seems plausible at first but was quickly disproven by facts. In 2006, scientists from Stanford University revealed the truth through an experiment. The scientists used synchrotron accelerator technology to analyze the blue pigment on the terracotta figures. A synchrotron accelerator is a device capable of emitting rays brighter than sunlight. And the scientists used it to shine on a blue pigment layer only 50 micrometers thick. The experiment results showed that the molecular structure of the blue pigment on the terracotta figures is similar to that of Egyptian blue, suggesting that it is indeed an artificially synthesized blue pigment. However, upon further analysis, scientists found that the chemical composition of the blue pigment on the terracotta figures is not exactly the same as that of Egyptian blue. The main component of the terracotta army's blue pigment is copper barium silicate, while Egyptian blue is made of calcium copper silicate, meaning their chemical compositions are entirely different. Additionally, the blue pigment on the terracotta figures contains lead monoxide, which helps make the blue appear brighter, even giving it a purple sheen. After a series of experiments, the academic community confirmed that the blue pigment on the terracotta figures was independently developed by ancient Chinese artisans, demonstrating a high level of scientific and technical achievement. To highlight the uniqueness of this pigment, it was named Chinese purple. This name symbolizes both the preciousness of this color and the fact that purple has traditionally been considered the most superior color. Therefore, Egyptian blue, Maya blue, and Chinese purple are referred to as the three important artificial blue and purple pigments created before the Industrial Revolution. Moreover, as scientific research advances, more and more mysteries are emerging. Scientists have discovered that the China purple pigment might hide some unknown black technology behind it, because the chemical elements it contains, such as copper, barium, and lead, coincide with the composition of modern superconducting materials. So, could China purple also possess superconducting properties? Scientists are filled with anticipation about this. As is widely known, superconducting materials are the holy grail of current scientific and technological advancements. They are key to solving many technological challenges, such as magnetic levitation, artificial suns, and quantum computers. If China purple is proven to have superconducting properties, it will open new frontiers for the development of human technology. To test this hypothesis, in 2006, scientists sent the China purple pigment from the Terracotta warriors to the U.S. National High Magnetic Field Laboratory, where the world's strongest magnetic field instruments were used to conduct superconductivity experiments. During the experiment, scientists observed that the molecules of China purple first transformed into a single magnetic wave. Then, these magnetic waves changed in three-dimensional space, splitting into two independent two-dimensional magnetic waves, and eventually became superconductors. This experimental result excited the scientists. It not only confirmed that China purple has superconducting properties, but also provided a new perspective for future superconducting materials research. Scientists believe that if they can understand how China purple transforms from three-dimensional magnetic waves into two-dimensional ones, humanity might be able to create more efficient and powerful superconducting materials. However, this brings up another question: how did the people of the Qin dynasty, over 2,200 years ago, synthesize this superconducting China purple? How did they think to apply this miraculous material to the Terracotta warriors? This remains an unsolved mystery. According to some archaeological experts, the synthesis of China purple is closely related to China's ancient jade culture. The ancient Chinese believed that jade had mysterious powers, such as the belief that a jade burial suit could prevent decay. A jade bike could protect the soul, and jade powder was thought to be a magical substance capable of granting immortality. Therefore, the ancients firmly believed that by mastering the method of making jade, they could achieve immortality, or even attain the path to immortality. To pursue this dream, the ancients eventually invented glass. The main components of glass included elements like barium and lead, which are also found in China purple pigment. Thus, it is possible that during the process of making glass, the ancients accidentally discovered this bluish-purple pigment and then applied it to the painted decorations of the terracotta warriors. But another question arises: since China purple is such an advanced artificial pigment, why has the color on the terracotta warriors faded? While other ancient pigments like Egyptian blue and Maya blue have remained vibrant on artifacts. Through scientific research, the main reason was found to be that not only was China purple and other pigments used on the terracotta warriors, but the surface was also coated with a layer of lacquer for preservation. Lacquer is a milky white natural liquid coating collected from the lacquer tree, known for its properties of corrosion resistance, high temperature tolerance, waterproofing, and gloss. In ancient times, lacquerware was a luxury item reserved for nobility and high-ranking officials, as the production of lacquer trees was extremely limited. Each lacquer tree could only produce about 0.1 kilogram of raw lacquer per year. Due to the rarity of this material, the ancients highly valued it, and it was widely used in the making of crafts and artifacts. One can imagine that, in order to ensure the terracotta warriors' colors remained vibrant for 1,000 years, Emperor Qin Shi Huang must have invested substantial resources, potentially using hundreds of thousands of lacquer trees. This was undoubtedly an extravagant investment. However, what Qin Shi Huang did not foresee was that, 1,000 years later, the raw lacquer he invested so much in would become the culprit behind the fading colors of the terracotta warriors. Archaeologists discovered that the rich water system and humid soil around Mount Li caused these terracotta figures to be buried in moist earth for an extended period. While raw lacquer has waterproof and anti-corrosive properties, the long-term effects of this humid environment led to the fading of the paint. If the tombs of the terracotta warriors had never been discovered, perhaps their colors would have remained bright. Nevertheless, raw lacquer, being a natural coating, is most sensitive to environmental changes, particularly fluctuations in humidity. Ancient items coated with raw lacquer, such as the terracotta warriors, had to be kept in a constant humidity environment. If there were drastic changes in humidity, the moisture in the lacquer would begin to evaporate, causing the coating to deform, crack, and fade. Especially when the tomb of the terracotta warriors was opened after more than 2,000 years, the stable humidity environment was disrupted, and the warriors were exposed to air. The rapid evaporation of moisture from the lacquer caused dramatic changes to the appearance of the figures, even resulting in cracks and fading. What's even more surprising is how quickly this process occurred. Once the terracotta warriors were exposed to air, the entire process of cracking and fading took only a mere 4 minutes. To address this issue, scientists from both China and abroad have been working tirelessly to research methods to prevent lacquer shedding and the deformation of the terracotta figures. However, up until now, no effective solution has been found. After all, once the terracotta warriors are unearthed, they can only maintain their original appearance for a very short time, making this an extremely difficult task. For this reason, the mysteries of pits 5 and 6 of the terracotta army have yet to be fully uncovered. Perhaps, with future advancements in technology, the terracotta warriors can once again display the brilliant splendor they had 1,000 years ago. It is worth mentioning that, aside from the mystery of the pigments used on the terracotta warriors, there has been ongoing debate about whether these statues were made using real humans. After all, each terracotta figure is lifelike, with unique forms that give the illusion of being real people. Many visitors to the terracotta army find themselves curious, how did the ancient craftsmen achieve this? To solve this puzzle, scientists conducted a big data study on the terracotta figures. They input the facial feature data of 100 terracotta warriors into an Asian facial database for comparison. The results showed that the facial features of all 100 statues matched the standards for Asian faces. And each figure's ears also displayed distinct differences. Some ears had larger earlobes, others had thinner ear shapes. And even the position and depth of the ear holes varied. This indicates that the facial features of the terracotta figures were not randomly sculpted, but were shaped based on real human characteristics. Furthermore, the scientists input the height, weight, and body proportions of the statues into a database for comparison. The results showed that the proportions and dimensions of the terracotta figures were highly realistic and not patched together. This further proves that the statues were not based on the imagination of the craftsmen, but rather on real people, suggesting that the terracotta warriors could represent actual historical individuals. Historical records mention that once, while digging, a villager accidentally broke a terracotta warrior. Scientists discovered that the inside of the statue was hollow. Additionally, after experimental analysis, no human hair or cellular tissue was found in the fragments, proving that the statues were not made using live humans, thereby dispelling that myth. So, how did the ancient craftsmen manage to create these lifelike terracotta warriors? Archaeologists have provided an answer. The key was the invention of two methods: coil building and kiln building by Qin dynasty craftsmen. The so-called coil building method involved the craftsmen gradually stacking clay in circles to form the model. then finally carving details based on the real appearance of the person. The kiln building method was an ancient technique invented to cope with the high temperatures of an environment without air conditioning. It allowed the craftsmen to maintain a constant temperature inside kiln caves while producing the terracotta warriors. As one of the most significant discoveries in human civilization, the terracotta army has become one of the 8 wonders of the world, with immeasurable research value. Today, the China purple pigment used on the terracotta warriors has been proven to be a superconducting material, and scientists are gradually unraveling this mysterious black technology. It is believed that, in the near future, more of the mysteries surrounding the terracotta army will be solved. Let us wait and see, looking forward to the day when all these enigmas are revealed. This is the History and Culture channel. Liking and subscribing are the greatest help and support to us. Thank you everyone and see you in the next time.